Hello, this is our second video about prototype modeling. And in this video, we're going to do an example using Maple to try to generate a 3D printed object. And to start us off, we're going to begin with this year's worth of gas bills, natural gas bills for my home. And intentionally, I've started month 0, month 12 to be the same month. And we'd actually like to generate a vase using these values. And so let's just plot a trend line. And a polynomial might make a nice trend line, so let's try that. And we can do different orders. But I'm going to go to order 6. So that looks pretty good. So if you can imagine this shape being rotated around the x-axis, you might get an interesting design. But the question is how is that going to print when my scale on the x-axis and on the y-axis are not equal? And so if we go to Maple, we can get an idea. So here on Maple, I just copy and pasted that polynomial from Excel into Maple. So here it is. And if I plot it, notice I'm plotting from 0 to 12 because that's my months, and 0 to 180 because that's the most my bill was $180. And so it looks okay, but remember when you print, it's going to assume all these are millimeters. That's the default setting for the 3D printer. And I get something that doesn't look good at all. So we need to scale this. And we can go back to Excel and practice scaling it. For instance, we could say take these values and multiply them by 15. And notice that gets them to be more in the order of magnitude of our bill. And we could even take these values and divide them by 2 to get them to be a little smaller. And I might decide maybe some of these are still too wide because I don't want a really wide vase. And so I might multiply them by 0.4. And so here I have some values that if I plot them, all right, so let's plot this and then add a trend line. Once again, we want a 6-degree polynomial. And our shape hasn't changed, but in a way it has because the scales are different. And so now we're going to get maybe a more natural, pleasing looking vase than before. So when we generate this actual 3-dimensional object on Maple, we need to take that into account. And the way we're going to do that is by dividing the x values by 15. That will spread out the x-axis, and then multiplying the function values by 0.4. That will shrink the y-axis. And then I'm just going to shift it down 1 to kind of get it a little bit tighter to the x-axis. And the other thing I'm going to do is, because if you notice on our vase, we have a pretty narrow base, and so that may not be very conducive for standing up. So I'm going to shift this over, basically eliminate the first 10 units here so we get a little better base. And so that's the reason for starting here at 10. And sure enough, here's our plot. And notice when I square the axes to be equal in both directions, we get what appears to be a nice outline. And if we want to parameterize that, we can get a 3-dimensional image. Again, make sure that it's squared up. And here's our vase. Now, notice you can also interpret this from a mathematical point of view. If I look at it like this, we can see how my gas bill varies in the summer when there isn't much reason to have the heat going, maybe just the water heater a little bit, versus the winter when it's very cold and I'm spending a whole lot more on natural gas. So that's one way of thinking about the vase. But if we just like the shape of it, then we can export it as an STL file. And if I'm going to do that, I just need to give this a name. Maybe I'll call it vase, colon equals. Let me reevaluate everything so Maple knows that I have it. And so it doesn't take too long. Should do all that. And then I can type the export command. And it's export, and then whatever I want to call my vase, maybe I'll call it gas bill vase.stl. That tells Maple that I want it to be an STL file, and then whatever I named this actual image, and if I hit enter, it will take a moment, but it should download a file on my computer with this name using this image, and this just gives you an idea of the size of the file. So that's it. And then I take it to the slicer and 3D print it. I won't go into those details, but here's what the final shape looks like, which, as you can see, was a nice faithful representation to the original design we had on Maple. So that's it for this video. Check out our next one. We'll take a look at OpenSCAD.